times in a single second, and this is called reentrancy attack. Today I am going to show you how this red malicious contract uses a simple loop to trick the green victim into giving away all the money before it even realizes what happened. Imagine you are at an ATM. You ask for 100 rupees. The machine gives you the cash, but before it can subtract the money from your bank account balance, you hit the withdraw button again. Because the machine hasn't updated your balance yet. It thinks you still have the money and gives you another 100 rupees. In the world of Web3, this glitch is called as a reentrancy attack, and it has cost the crypto world billions. Now I'm going to explain this reentrancy attack more deeper using this flowchart of three buttons. So, on the victim contract, which is a green one, this is the ATM. It holds the funds and has the logic error. The malicious contract, the red one, is the hacker. It is designed to automatically call the victim back before the victim can finish its first attack. So the helper contract, which is the yellow one, the middle one, often uses to bypass certain security checks or to trigger the fallback function that starts the loop. So how the attack actually works means the bait. The malicious contract calls the function on the victim contract. It basically says, I would like to withdraw my one ether, please, and then the transfer. The victim contract says, sure, you have one ether, here it is, and sends the funds to the malicious contract. The interrupt, it is the core of the attack. This is the trick before the victim contract can move to the next line of the code, which would be now subtract one ether from their balance. The malicious contract uses a fallback function. A fallback function is like automatic thank you, not not the triggers as soon as it receives money. But instead of saying thanks, the malicious contract note says, wait, while I'm here, I would like to withdraw one ether again. The loop, because of the victim contract hasn't finished the first transaction, it records still shows the hacker has a full balance. It thinks, oh, okay, you still have one ether, and it sends it again. This creates a loop re-entering the contact, and that's why it's called as reentrancy attack that drains the victim's funds until the contract is empty. So, why does this helper exist is a doubt that maybe arise. It's because in the specific diagram, the victim creates a helper contract. This is often seen in more sophisticated attack, where the victim doesn't send money directly to the attacker, but interacts with another contract first. The hacker exploits the fact that the victim is waiting for the helper to finish, using the window of the time to strike again. So, how to prevent this means developers prevents this using two main methods like checks effects interaction pattern and re-entrancy guard. This is a mutex. So in the first way, always update the user's balance to zero before sending them the money. Even if they call fallback, the record will show the same. The reentrancy guard, which is a mutex one, it is a simple lock that says if I am already in the middle of the transaction, then don't let anyone else or the same person even start a new one until I am done. So this is where it happens. Now let me demonstrate how it's actually work using this guide using the remix IDE. So let's create a new folder called Reentrancy Demo. Inside that folder, I'm going to create a new file called attacker.sol. Since this is a solidity file, we have to save this file with the extension called solidity. So there is a two thing like victim and attacker. So the victim's solidity file is named as solidity reentrancy. attacker file, also reentrancy, solidity reentrancy dot sol. This is the victim file. So let's copy the code and paste it in the ID. So using this instruction and step by step, we can able to demonstrate how this reentrancy attack actually works and what is the magic behind. So in the step 1, we have to compile both the contract. So in this IDE, to compile a contract, we have a button compiling. So this in this place where you get all the configuration of compiling and deployment, it shows the actual successful or errors happened during the compilation. So once both the contracts successfully compiled, we have to move to the step 2, which is the deployment of the victim contract, which is the solidity reentrancy file have to be deployed now, and we have to copy the contract address. Once it is successfully deployed, you will get this a card like appearance, which is only a deployed contract will come. Through here we can copy. Also we can check the configuration um, inside this page. We can copy this contract address. Once it is copied, then the step 3 is to use a deposit function to demonstrate the deposit of the victim contract. So let's deposit the victim contract using let me give 5 ether. Always choose ether, and once it is transacted successfully, you will get the address here, and to which account it was transferred or deposited, and that address will come here. And also we will get all the other output details in this area. And once it is deposited, step 4 is to deploy the attacker account with the help of the victim's contract address. So now let's go to the attacker's account, and it was already compiled. So now we have to deploy this. It's compiled. To deploy the attacker solidity file, we have to give the victim's address. So once it is given, we can deploy it. So it is successfully deployed, since you can see the address here. So once it is deployed, we have to run the attack function with 1 ETH. So what I'm going to do here is, once I have done all the basic things, now I have to, as an attacker, I have to attack the victim contract. No, for that I have to call the attacker function in the attacker's contract. So I'm just going to pass 1 ether. Like, I'm as attacker, I'm going to send 1 ether to trap the victim, to drain all other complete balance in the victim's account. So it is done successfully. So if I check the balance of victim, it will be 0, and if I check the balance of attacker, it will become 6 ether. So this is the reentrancy attack. So what happens internally here is, attacker deposits 1 ether basically, and this calls withdraw function. The victim sends ether using dot call function, and then attacker receive is triggered. It calls withdraw again and again until the victim's balance becomes 0, and this loop continues and triggers until it drains the entire victim contracts. And finally, the victim contracts become zero, and attacker contract balance becomes increased with totally 6 ethers. And this is the and still the mapping still shows the incorrect state during attack. So to prevent this, we have to check the contract of the victim before we compile or deploy it. And thank you.